let's start a problem string. Okay, these problems are going to be based on the video we watched about bunnies and viruses. So I'm going to give you a problem, and I'm going to ask you to predict how the function and graph would change if the scenario changed as described in the new problem. So I'm going to write on here problem string. It's called parameters. So our first one, we are going to start with 2 rabbits, just like we did in the video. 2 bunnies. And then they are going to have 6 babies every month. So let's write the function rule. So our f of x equals, how do we write our function rule? If we start with 6 and they have 6 babies every month.
6x plus 2.
6x plus 2. How did you know that 6 was with our x?
Because it happens every month.
Because it happens every month. That's like our rate, yeah. Rate or slope. Predict what the graph would look like. What do you think the graph is going to look like?
It's going to raise up. It's positive.
Mm-hmm. Okay, so you think it'll be exponential? It'll raise up. Let's talk about it. Let's just draw quadrant 1 because you're starting with 2, right? I'm going to go by 2s. How about that? I'm going to go by 1s on the x-axis and go by 2s on the y. Okay, so I'm starting with 2, and then I'm going up 6 every month. So what would be for 1 month? 8. This doesn't really help me much, does it? So I need to do a better job. What do you think our y's should go by? Maybe 5s? I'm going to rewrite it. Okay, so it's x, 5, 10, 15, 20, 25, and 30. Okay, let's see how many we can get on here. So x represents months, and y represents number of bunnies. So start out with 2. And then after 1 month, how many do we have? 8. And then after 2 months, 8 plus 6 would be 14. Yeah. Okay, what about the next month? What about the next month? What about the next month? Okay. So we can get quite a few on there. right, so we are going to put this in our calculator now. So get out your calculator after you draw your line. I'm going to clear out my memory because I have a lot of stuff in there from all the stuff we've been doing lately. So let's go to y equals, and let's put this function in. 6x plus 2. Put it into y equals. All right, this shows me my standard view. If I go to zoom, there are different options. And we also have another way of looking at this or adjusting it, because remember we're talking about parameters. So our parameters are, how could we make our viewing window or our graph to show as much data as possible to give us a better idea of what it's going to look like and how many, or information about the scenario, really. So I want to change my look in here. Do y'all remember what we can do to change our look? Zoom. Zoom stat is if we have data in our list. So no, we can do zoom in, but that doesn't give us a way to have control over it. So what we can do is we can actually change the window. So let's click on window. And this is like, we have the whole world outside, okay? But we can only look through that window right there. You can only see part of the world. Same thing with this graph. You have a line that goes to infinity in both directions, but we want to look at our window to be able to just see this part right here. So we're going to change our window. So it says x min. So that's our minimum x value. So if we look at our x's, what do you think our x minimum should be? 0? What if I want just a little bit over so I can still see this line? Okay, -1. Okay, so let's change that to -1. What's our x max? What do you think we should go to? Yeah, we can go to 6. Okay, scale. What is our scale, SCL, going by? Yeah, 1. Okay, now we're on to y min. What should our y min be? I want to go just a little bit below so I can still see that line. -1. Max, what do you think our y max should be? 30 is here, but what was that highest one? 32. So let's go a little bit above 32. What do y'all think? 35. Okay, what are our scale? What should we go by on our scale? Yeah. And then we don't change anything else. Okay. Then you hit graph and look how it changes your graph. So now I can be really specific about how I want my graph to look. Okay, so what we're really doing when we change our window, we're thinking about domain and range. Do y'all remember those? What was our domain? X values, right. So what were our X values? Right, yeah. X equals 1, 2, 3, 4, right? 5, and so on. And the reason we would list the numbers is because X represents months. We are only counting how many bunnies there are at each month. Like, let's say on the 31st of every month, we're counting the babies, or the total bunnies, really. Okay, what about our range?
14, 20.
2, 8, 14, 20, and I'm going to do dot, 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 and so on. Can you have part of a bunny? No. So that's why we're listing them out. This is called discrete. Y'all remember discrete and continuous? Man, this was a long time ago. But this is considered a discrete situation because you can't count parts of a bunny, or we're not counting parts of the month. So this is all for the situation. The domain and range for the situation. But what about for that function, f of x equals 6x plus 2? Let's find our domain and range for that. So if I'm looking at the function here of f of x, 6x plus 2, I would connect the dots. If I'm just looking at the situation, I would just look at the individual discrete data, just the dots. So for the domain, what are the possible x values for the function? When we look at it, let's go to 6x plus 2. I want to go back to the graph looking like it was in the beginning. So I'm going to go to zoom standard, number 6. So now I'm not thinking about the situation anymore. I'm just thinking about the function, just that 6x plus 2. So what is the domain? What can the x values be on the function? The glare is bad. X can be anything, right? From negative infinity to positive infinity. So that's what our domain is. Negative infinity is less than x is less than positive infinity. Vaguely remember that?
Yeah.
It's been a while. So x can be any number from negative infinity to positive infinity. But the range is our y values. What can our y values be? If I go down, can I go all the way down to negative infinity? Mm-hmm. And can I go all the way up? And that line is reaching. It's continuing on. Because remember, we are only seeing a window. But it goes on and on to infinity. So this would be negative infinity to infinity. So this is dealing with the linear stuff. So now let's talk about, let's do another one. Problem 2. We're going to start with 2 rabbits. I don't like writing rabbits. I'd rather write bunnies. And have 2 every month. So how is this scenario different from that?
It's going by 2 instead of 6.
It's going by 2 instead of 6. So let's write our function rule. So the rate that it's increasing by has changed from 6 to 2. So this would be 2x plus 2. Okay, so what about for the situation? We're not going to graph it. We're just going to talk about the domain and range for the situation first. So the domain is your x's. So what could our x values be for this situation? Start with 2, have 2 babies every month. Yeah. What about month 0? Should we have included that? Because you're starting with 2. So really we should have included that up here. So put a 0 there. So 0, 1, 2, 3, and so on. And then what about the range?
1, 2, 3. I mean 2, 4, 6.
2, yeah. 4, 6, and so on. Okay, so even numbers. Okay, so let's put this in. So 2x plus 2. We need to change our window, so let's change our window again. So go to window. Do you think this would be okay to use still? Like if I graph it on here, why don't we just graph it on here? That'd be easy. It starts with 2, right? And then it goes up by 2 every month. So that's my first point. I'm going to graph it with a different color because, I like different colors. So after month 1, how many would we have? 4. Plus 2 more. So what would that be? 6. Plus 2 more. What would 3 months be? 4th month? 5th month? 6th month? Okay. So we could keep our same window or we can change it. But let's go ahead and change this window. So everybody get on their window screen. So X min, let's go to 1. I think X max of 6 is fine. Scale, you should be changing your window. Y min, -1. Y max, we can still keep it at 35 because I think I want to actually put these on the same graph. Y scale, 5. Okay, let's graph it. Okay, so that's the green one on mine. So the function looks like that. I'm going to go ahead and put the other one on there too. So in Y2, I'm going to put the 6x plus 2. That way I can look at them together. Okay, so for the domain and range of the situation, we already figured that. What about the domain and range of the function? So the function is the graph with the points being connected because the function is f of x equals 2x plus 2. So what can our x values be for the function? Situation 0, 1, 2, 3, but the function, x can be any number. So it's negative infinity to positive infinity. And then the range is the y values. It goes to infinity, negative infinity, and positive infinity also. So at your table, I want you to talk about how these two situations compare, number 1 and number 2. How do the situations compare and how do the functions compare? Okay, Carter, y'all's group.
They started out with the same amount.
Okay, so that's a thing that's the same. So, in common, I'm going to just put in common. What did they have in common? And that was the starting amount. Okay. And then what about different? Bree, y'all's group. What did they have that was different? Okay, so in the situation, where is that found? What is slope in the situation? What does it represent? What? Number of bunnies, what? They have every month. Because that's our rate. Number of bunnies they have every month. Okay, so in our function, where's this at, basically? So like our starting amount, where do you see that in your function rules? Abby, Kate, y'all's group. Where do you see the starting amount in your function rules?
The y-intercept.
Okay, so I'm going to put that y-intercept. And then rainy, no, I already called on y'all's group. Rainy month. Where do you see number of bunnies they have every month in the function rule? Mm-hmm.
So wouldn't that be the x?
The number in front of x.
Then the slope?
So, yep. Which is what Bree said a minute ago, too. Okay. Cool. All right. So with linear, we know that the starting amount is our y-intercept. The rate is found with our slope. Okay, let's go to number 3. I'm starting a new page because, all right, there. So this time we are going to start with 4 and have 6 every month. Go ahead and write the function rule and predict what the graph would look like. And graph it in your calculator using a good window.
So do we need to put our graph on?
Nah, we won't graph it on our paper this time. Katie, what did y'all get as y'all's function rule?
Number 6,
Yes.
6x plus 4.
6x plus 4. Okay, good. Delete that one. 6x plus 4. Graph it. Do you think that viewing window that we made earlier is okay?
Yeah.
Yeah, I think so too. Okay. So let's look at, for the situation, the domain and range. Domain and range. So for the domain, what are the x values?
0.
Yeah, x equals 0, 1, 2, 3, so on. Then the range.
4, 10, 16, 22.
4, 10. So it's going up by 6, 16, 22, and so on. Okay, cool. But for the function, what is going to be the domain and range for the function? Mm-hmm. Yep, it goes from negative infinity to positive infinity. I'm not going to worry about writing that because it's been the same this whole time. Okay, let's go to the fourth one. Let's see, what is the fourth one? We're going to change it up. We're going to start with 3 viruses. And they increase or multiply by 5 every day. This one will graph. So let's see. What would be our function rule?
3, I mean, it's 5x plus 3.
And 3x. No, yeah, 5x.
Let's make a table. I think the table really helps. So let's say X is days, Y is viruses. So on day 0, how many viruses do we have? 3. Day 1, how many do we have? No, because it's multiplied. Remember the viruses, how they increase rapidly? So it's multiplying by 5 every day. So it'd be 15. Yeah. Okay, what about the next one?
Wouldn't it be 15 times 5?
15 times 5, which is, yes, 75? Okay. The next one? What'd you say? 375? Okay. I can't hear very good. Okay, what about 4?
1,875.
Okay, so we'll stick with that. So let's see, what would be our function rule? How do we do it? How do we write the function rule whenever you start with something and multiply by 5 every day? How did we get 15?
Multiply 3 times 5.
3 times 5. How did we get 75? 3 times 5 times 5. 375?
3
times 5 to the x power.
Right. Yes. So it's 3 times 5 to the x power. So 3 is your starting amount. The multiply by 5 is the base of your exponent in your exponential. Okay, so what I want y'all to do is make your quadrant 1. We need to make our window. So what do you think the y value should go by? Let's get What if we just do the 0 through 3? What if we do those? So we need to get the y values to get up to 375. 50. Okay. Oh, that would be 400. I don't know why I did that. Okay, so what I want y'all to do is for tomorrow have this done. Okay, that's the only thing you have for homework for tonight, other than finishing the assignment from yesterday.